Hi everyone, we are looking at Unit 6, Lesson 4. And so we're still in our unit about functions, so we can see lots of different types of function families. So to start, I want you to answer this top question there. Is it possible to build a patio like that? And then use any strategy that you want. And then when you're ready, you can restart the video. All right, so I'm actually not going to spend too much time on this top part because the questions underneath are meant to help us figure out how to approach this problem if we weren't quite sure. So your answers up here could vary, but we're going to look at specifically for functions what it would look like, how would we approach this problem. So we are asked to write an equation for the area, and looking at number 2, equation for the perimeter, and you can use whatever variables that you want. So if you want to pause the video and work ahead, fantastic. And then when you come back, I'll kind of go through them. So if we're looking at area, we are multiplying length times width, and we know that our area will be equal to 168 because that was the amount given to us in our top paragraph. And L represents the length while W represents the width. So some points that satisfy this equation, if I choose any length, I can plug that in and then solve for width. So for example, if I say my length is 2, my width would have to be 84. If I plug in 2 for L and W for, 84 for W, I multiply those, I get 168. So you can find other points that work. There's multiple options. I'm just going to list a couple out here. And then for question 2, it says to write an equation for the perimeter. So we know for perimeter, we add up all the sides. If we have a rectangle, we're adding up our 2 lengths and our 2 widths. So we could do length plus width, and that'll equal 52. And then I know that if I have L plus L, that would be 2L. Same thing with the W's, 2W equals 52. So I have my equation for the perimeter, and then similar question as before, I want to list some points that satisfy it. So I can pick any value for L, plug that in, and solve for W, or vice versa. So there's lots of points that work. I'm just going to list a couple of them. I want this video to be a reasonable time frame. That's why I'm not spending time showing how I find those points. I believe that you can plug in values. So now that we have 2 equations, I want to take a second to identify a couple things. For number 1, because we were multiplying 2 variables, this is actually a non-linear equation. It is not a straight line if we were to graph that. And then in number 2, this was a linear equation. So if we go on to Desmos and we graph these, I probably would use X and Y if I was talking about Desmos. And I can see what those 2 lines would look like. So for number 3, it says you've created 2 equations that make a system. Write and graph the system below. So I have LW equals 168, and I have 2L plus 2W equals 52. So I'm going to actually pull up Desmos real quick, and I'm going to project that on the screen here. So let me type in my equations, and I'm going to do X for my length and Y for my width. And then let me do my other one. I have 2x plus 2y equals 52. Now I can't see anything, so I want to zoom out a little bit here, and this is kind of what my graph looks like. So let me zoom back in to see what's happening. And it looks like it crosses at 12:14 and at 14:12. So I'm going to kind of sketch that on my graph and then kind of summarize question number 4. So let me get rid of Desmos. So we're back here, and I'm going to just do a quick sketch because we use Desmos. So I'm going to do by tens, and I could plot the actual points and draw a line for each equation. What ends up happening is I have my linear graph that looks something like this one. This is my linear, and that came from question number 2. And then for my other one, I can plot a couple points here. So 8 is somewhere here. I know it hits 12:14 and 14:12, and then 21:8. And this is my non-linear function, that curved one there. So I want to label a couple things on this graph. There were 2 places that we saw intersections on Desmos, and these I'm going to label. Anytime we have an intersection, that means that they are the solutions to the system. So intersections equal our solutions. So for question 4, find the intersection of the equations. Well, we saw on Desmos it was 12:14 and it was 14:12. So what that means is we can have a patio with a length of 12 and a width of 14, or we can have a patio with a length of 14 and a width of 12, and that would satisfy the area and the perimeter. So let's kind of summarize that here. And I realize we kind of can't see what I'm writing, so let me scoot that a little bit. All right, so we can have a patio with this length and width or this length and width, and they will both give an area of 168 feet and a perimeter of 52 feet. And so something I want to include in red here as like something to stand out, our solution to a system is a coordinate point. Not just one variable. We had to find the length and the width. So if I look here, I could say 12 is my length, 14 is my width, and then this one, 14 is my length, and 12 is my width. So I'm not just finding one or the other. I have to make sure that I have a coordinate point, a solution to each variable. So now let's go ahead and flip to the next page. We're going to look at a couple together. So at the top here it says solve the system of equations by graphing. And yes, we could graph this by hand. We have a radical, and a radical function is a function whose parent function has a starting point and it kind of goes off into a wave. And then we can think about transformations. It's going to the left 1 and down 2. And then absolute value is a V shape, and it's going right 5 and down 2. So I could graph it that way. What we're going to do is we're going to utilize our graphing calculators because that'll save us some time and it can calculate the intersection point for us. So make sure you have a graphing calculator out. And we're going to graph it on here, and then we'll just sketch it on our graph so we have it in our notes. So what we're going to do is hit our y equals button, and I want to type in each equation because each equation is already y equals. So I'm going to start with the top one. I have the square root. So my square root is right here in blue. So I'm going to do second x squared. I'm going to use this button for my x, so x plus 1. To get out of my square root symbol, I'm going to hit my arrow to the right and then minus 2. Double check that it matches. And then for my second equation, I'm going to arrow down. Now I have absolute value bars here. They are not parentheses, so we have to get the absolute value sign differently. We are going to hit our math button. Our math button is on the left underneath our green alpha sign. So hit math. And then we're going to hit our arrow to the right, so we're under the number category. So arrow to the right. And that very top one says abs. Abs is absolute value. So when I choose it, I can see my absolute value bars. Sometimes it still says the word abs depending on if you have like a TI-83 versus a TI-84. So now I can type in x minus 5. I want to get out of my absolute value bars for the minus 2. Double check that it matches. And now I want to look at my graph. So I hit my graph button. So I can see both of my equations. The first one here was my radical, and then my V shape is that absolute value. So I notice that they intersect here and here. So I'm going to have two solutions for this one. So I'm going to scoot this to the side, and I'm going to sketch it kind of quickly here just because I already know where it's at. But if we use our graphing calculator, you really don't need to sketch this. But it's nice to have a visual when we're looking back on it. So that would be my absolute value. And then my radical, that first equation, kind of goes like that. So the calculator can do the work for us. So what we're going to do, I want the lighting to be good here, is we want this calc feature because we want to calculate something. So we're going to hit second trace because it's in blue. So we're going to do second trace. And we want to calculate where they intersect. So we're going to go down to option 5 and hit enter. And now it says first curve. So I have my, it's called a spider, my blinking spider. And I just want to move it closer to the intersection point. And I'm really just making sure that it's on which line it's on. Right now it's on my radical, so I can go ahead and hit enter. Then it'll say second curve. I want to make sure that it now switches to my absolute value graph, which it did. So I hit enter. And then for guess, I'm going to move that blinking dot close to where the intersection point is. And I'm only doing one at a time. So I'm going to move it about there and hit enter. And our first intersection is at an x value of 3 and a y value of 0. So on our notes, we're going to say 3, 0 is a solution. We're going to do it again. And now we're looking for our other intersection point. So I'm going to do second trace. I want to calculate where they intersect. First curve is on the radical, so I hit enter. Second is on the absolute value, I hit enter. And then I'm going to go to the right to get this other intersection point, somewhere around there, I think. Hit enter. And then 8, 1. And I have my two solutions. So I want you to do number 2 using your graphing calculator to practice this. And then when you're ready, restart the video. All right, so for number 2, let me just scoot my paper up a little bit here. We can do the same thing. I'm going to do x squared plus 3x plus 2 my second equation, and then I want to look at my graph. I notice that I still have two solutions. They intersect here and here. So I'm going to calculate where they intersect. The first one is at -2, 0. And the second one, let me go to the right, somewhere around there, 1,6. And you'll notice I kind of did that fast. When you guess, it doesn't have to be perfect. As long as you're pretty close to where you think it is, the calculator does the hard work. So we have our solutions. Now, I want to show you, if you forget how to do it, there is another way to solve this one. If both of our equations are equal to y, what we could do is I could take all of this, and because y equals all of that can go into y there. And I'm basically setting my two equations equal to each other. So I would have x squared plus 3x plus 2 equals 2x plus 4. And this would be how we solve it algebraically, and we're actually using substitution. So I'm going to make a little note here. Let me put substitution. And now I want to solve this quadratic. So I need to move my 2x to the other side. So I'm going to subtract it from each side of my equal sign. I also want to move this +4, so I subtract it from each side. So on the right-hand side, those will end up canceling out to 0. I have x squared. 3x minus 2x is 1x. 2 minus 4 is -2. I can factor this, numbers that multiply to -2 that add up to 1, and that would be +2 and -1, so I can write it in factored form. I set each of these equal to 0, and I get x equals -2 and x equals +1. Now, if I solve it algebraically, right now, all I have are the x values. I don't have a full coordinate point. So I want to take each x value and plug it in to find my y value. And we should be able to choose either equation, and we'll get the same y value for both. So because of that, I'm going to choose the easier equation. I'm going to plug x into the bottom. So 2 times my x value of -2 plus 4. 2 times -2 is -4. -4 plus 4 is 0. And that makes sense because the first point we got was -2, 0. When I plugged in -2, I got 0. And then I'm going to plug in 1. 2 times 1 plus 4. This would be 2. 2 plus 4 is 6. So 1 gets paired with 6, which matches our other point. So you could do it graphically with your graphing calculator, or we can do it algebraically because we know how to solve quadratics. I want to talk about number 3 briefly because this one's a little different. It says, consider the given system of equations. And what method would you use to solve? Explain your choice. This one's different from the top two because the bottom equation says y equals, the top does not. Which means we would have to rearrange it to be able to type it into our graphing calculator. If we rearrange it, we would have to take the square root to get y by itself, and we're actually changing the equation then. And so for this one, because we have like y squared, I'm gonna put that like in quotations, you can use Desmos. So you can type in these equations exactly how they look in Desmos, and what you should get is you should get a circle. This top equation is a circle and then a linear function. But I want to show you how to do it algebraically, or at least to start it. So we did an algebraic one in number 2 here, and I'm going to apply those same skills to number 3. So because y is equal to 3x, I can plug in 3x for y in my other equation. So that will look like x squared plus, I'm plugging 3x in place of y, it's still being squared, equals 40. I want to evaluate this, so the x squared is staying there. 3 squared is 9, and the x is being squared, so both of them got squared. Well, now I have some like terms here. 1x squared plus 9x squared gives me 10x squared. I'm going to divide both sides by 10. I get x squared equals 4. And then I can take the square root to get x by itself. Whenever I take the square root, I get plus or minus, whatever it is, so plus or minus 2, which means I'm going to have two solutions. One will have a positive 2, comma, whatever y value. The other will be negative 2, comma, whatever y value. So similarly as before, I want to take each and I want to plug them back into my equation. It doesn't matter which one, so I'm still going to choose the easier option. I'm going to choose the bottom. So if I plug in positive 2, 3 times positive 2 is positive 6. 3 times negative 2 is negative 6. And these would be my two solutions. If you were to graph it in Desmos, you get the same exact ones. Your graph would look something like this, where you have a circle for that top equation, and then you have a linear function going through diagonally like that, and this would be 2, 6, and this intersection point would be negative 2, negative 6. All right, let's fill in our key points so you have some time to practice. So on the next page, we have a table. If we're solving systems using a table, we can guess and check or look for patterns to find when both constraints meet. And because we're like guessing and checking or looking for patterns, it can help us estimate, but it might not get us exact answers, especially if there's going to be like decimals. So not the most reliable, but it can help us kind of get an idea. In the second row here, solving a systems with a graph, we want to graph both equations, and we want to find the intersection. So where do those equations cross or meet? If we're doing it on a graphing calculator, after both equations are graphed, we can do this. So we want to calc, which is second trace, option 5. It is option 5 on mine. It might be a different number, but we're looking for intersect. You're identifying your first curve or your first graph, your second curve or your second graph, and then guess, and it'll give you an x value and a y value. We still want to write our solutions as points. If the question asks you to explain in context of the problem, you would not write them as points, but you should still have like a pair of numbers because you're going to have two variables, so you need a number for each variable. Some special solutions: if there is no intersection, then there are no solutions. And that would be if we have some parallel lines. They don't intersect and they will never intersect, so there's no solutions. If our graphs are exactly the same, so if I had a linear function that looked like this, and I had a second linear function, and when I graph it, it graphs right on top of it, where it would be the exact same, we actually say that we have infinite solutions because every single point on that line is a solution, and this line goes on forever in both directions. Lastly, we want to look for structure that makes solving with substitution or elimination easier for you. So if you think it's going to be easier to use substitution instead of a graphing calculator, fantastic. If you think using a graphing calculator is going to be easier, fantastic. You're looking for what makes sense. If it makes more sense to do elimination versus substitution, or vice versa. So try some practice problems on the bottom and then check your work with the key that is posted.